It is my personal opinion that 99% of modern illness, disease, and sickness is not genetic or inevitable. Most people think that humans just get sick at the rate and frequency that we see in modern society. And I used to be one of those people who just accepted the normalization of disease and illness, but I now reject that. We've normalized taking medications at such an early age for diseases that are easily preventable and just call it a part of the human experience. But it is my belief that the cause of this is our misalignment with our natural biology, and in particular, our modern diet. And so my goal with this video is to break down three key aspects of the modern diet that I've identified to be contributing most to our illnesses, and then paint a holistic picture of how I approach nutrition and what I think is the optimal approach for a human being. But before I do that, I want to shift your perspective over to the wild for a moment. I want you to think about every other species of animal, and in particular mammals because they most resemble humans. Each one of those species has a very specific, niche, biologically appropriate diet. Lions, for example, are hypercarnivores and they consume the animal flesh of various other large mammals. Gorillas, for example, are herbivores who consume mainly a couple plants that they prefer depending on their habitat. Panda bears are also herbivores who consume 99% bamboo, and the list goes on and on. Now, these animals consume their biologically appropriate foods with minimal to no variation. And the reason is because if they deviate, they will begin to suffer severe health consequences very rapidly, typically in the form of degenerative processes. For example, if you begin to feed a lion vegetables as opposed to animal flesh, it will begin to suffer severe nutritional deficiencies. And this is because not only are vegetables destitute of the required nutrition for a lion, but even if they were replete, a lion does not have the biological adaptations to actually extract nutrients from those plants. And one of the reasons for this is because lions don't contain the enzyme cellulase, which is required to break down cellulose, which is the main structural component of almost all plant cell walls. Interestingly enough, this is one of the ways that humans and lions are similar because humans also do not contain the enzyme cellulase. Analyzing anatomy is also a very valuable tool that we can use when determining why a specific animal in the wild eats the way it does. For example, another biological inference that we can make about lions is that they have a very short digestive tract. This is because meat digests relatively quickly, whereas herbivores require very long digestive tracts to break down very tough fiber and plant material. I already touched upon how a lion would suffer from severe nutritional deficiencies if it did not have animal flesh, and this is because it contains some of its essential nutrients, things like the active form of vitamin A, vitamin D, and amino acids like taurine, which are not found in plants. And we know that nutritional deficiencies lead to severe health degradation. If you've ever been to the zoo, you'll understand just how important this is. There are signs that explicitly tell the viewers not to feed the animals because they don't want anything inappropriate entering the cages or the areas wherever the animals are, because they know that an inappropriate food can have severe health consequences and even result in death. Anyone who's had a pet also understands the significance of this. Particularly cats and dogs, which are very common pets nowadays, can suffer from severe health consequences if fed inappropriate foods. Certain foods that are typically very high in sugar can also be lethal in relatively small doses because these animals are carnivores and they're not adapted to having high levels of blood glucose. But humans think we can eat a little bit of everything, including the chemically modified, industrially processed, so-called foods that aren't actually food and somehow avoid the consequences. But I think it's quite clear what the result of that has been. And to be completely honest, I don't blame anyone. This crisis is hardly the fault of the average person. The main factors that influence what any given person eats at any given time is typically a combination of cravings, taste, culture, and convenience. There are also people who try to consciously be healthy and make the healthy decision, but typically that manifests as them following the mainstream guidelines, which typically perpetuate the problem because they aren't actually based on any solid scientific data or experiment. But what I'm trying to say is that in nature, we would be eating instinctually. We wouldn't have to consider any of these factors, especially trying to consciously be healthy. Everyone understands that if we were just thrown into the wild, we would have to hunt and kill animals. maybe we'd find some occasionally non-toxic fruit, but we wouldn't just be eating plant leaves or grass because that would be completely counterintuitive. And our body tells us this because those things taste horrible. Nature would provide us with the tastiest foods, and our instinct would tell us to continue to eat those without having to consider whether it was healthy or not, because that food that nature provided us with is the healthiest option. Just like a lion doesn't have to consider if eating a zebra is healthy, or a panda doesn't have to consider whether eating bamboo is healthy. The problem is that in the modern world, grocery stores are packed with this industrially processed, chemically modified garbage, which has been designed with the specific intent to make us addicted. And because it's our natural state to consume what instinctually tastes good without really considering whether it may be harmful, what happens is we vastly overconsume an inappropriate amount of these modern foods. And one of the biggest contributing factors to this problem is that the damage being done by these foods isn't immediately visible or really visible at all on an internal level. You don't see the chemical reactions happening in your body as a result of these foods. You just maybe get a stomach ache and then have to go to the washroom 2 hours later. But just because that's over, that doesn't mean that you're in the clear. You don't see all of the excess glucose glycating your tissues, all of the excess omega-6 from the cooking oils oxidizing and creating damaging byproducts, or all of the sodium retention from the excess carbohydrate and salt intake simultaneously elevating your blood pressure. These are all things happening under the surface that you don't feel, that are accumulating over the years and decades until you're eventually 50 or 60, and then you have high blood pressure, diabetes, atherosclerosis, all of the main diseases that are killing people. And the killer is that most people will think it just happened by chance or that they got unlucky, but they didn't realize. And like I said, it's not their fault because they don't understand these things or see what's happening under the surface, but it's the accumulation of all of these poor eating habits over years and years, accumulating and causing damage. Now, this inappropriate way of eating might kill a dog or a lion faster, which is something I hear, oh, but we don't die right away when we eat bad foods. Well, it's because we live longer than those animals. So you'd have to analyze it as a ratio of the proportion of how long we're living to how long we should be living. And ultimately, we can only speculate how long we really should be living. I'm not an expert in anthropology or genetics, but I do know that experts within those fields have analyzed the human genome and analyzed them in comparison to genomes of other animals, and have estimated that we should be living to between 120 and 150 years. Now, that could be wrong, it could be right, but what I do definitely believe is that we should probably be living longer than we currently are because our habits are so poor. But I digress. Something I think about often is if people could see what was actually happening on an internal biochemical level within their body after they ate something, if they would still make that same choice. Because personally, I think a lot of people would think twice a lot more often, or even completely cut out some of their poor decisions from their life. For example, something like going to McDonald's is often deemed as worth it once in a while because the perception of how much damage is actually occurring is probably to be not that high versus the reward of how good it tastes. Like I said, people will just eat it, maybe get a stomach ache later, and then think it's over with. So they decide that every once in a while, for them specifically, however often, it's worth it to get it. But I think this is because they can't actually see what's happening under the surface. They don't understand how much damage is being done. And so as a result, on average, people overconsume or they indulge in these things more than they probably would if they actually realized what was happening under the surface. And as a result, what we see is the damage of those things accumulate faster and faster, and the disease rates increasing at a younger and younger age every year. So without rambling on for too much longer, let me get into number one of the three things that I wanted to discuss today. So the first big killer that I would call it, I guess, is seed oils. When I think about the biggest dietary changes that have happened over the last 100 years or so that have contributed to the rapid increase in modern diseases like obesity, diabetes, and heart disease, the biggest thing that comes to mind is seed oils. In particular, obesity and atherosclerosis, which or what I believe that seed oils cause most, more so than diabetes, weren't really super prevalent just 100 years ago. Like there weren't that many obese people, and heart disease wasn't a very common thing. Even just looking back to the 1960s, the average American man weighed about 166 pounds, whereas today he weighs about 199 pounds. And I'm going to guess that everyone didn't just start working out and we didn't gain 30 pounds of muscle. I'm going to assume it's fat just from looking around. But the point is that coincidentally, around that time is when these industrially produced seed oils became very popularized as heart healthy alternatives to the very demonized saturated animal fats. I can do a whole other video on how that was fraudulent and completely inaccurate, but for the sake of keeping this video more concise, I'm not going to do that right now. And once I start breaking down the biochemical mechanisms, I think you'll understand why I believe these to be very harmful as a modern inclusion in our diet. Because I don't want to just be one of those guys who say seed oil's bad. Like there are many people that do that and they don't really understand what the actual problem with them is. But there's also the other side of that argument, which is many experts saying that there's nothing wrong with seed oils because they view it from the mainstream lens, which is, well, we don't have any long-term outcome studies showing that seed oils cause any harm in humans. And that's true. But the reality is, unfortunately, that we don't have any long-term outcome studies informing us on the outcome of any diet or any food whatsoever at all. Again, I can make a whole other video, and I probably will, going into the flaws of human nutrition science and epidemiology. But before I do that, I highly encourage you to research it because I know you'll come to the inevitable conclusion that it is basically useless when it comes to its ability to inform us on what's healthy or not. So the point is, you can't view it from that lens. The mainstream lens is, oh, we don't have any observational associative studies that show there's any harm or any benefit. So therefore, X, Y, or Z is bad or X, Y, or Z is exonerated. The way that I like to determine whether or not a food is healthy or not, or whether or not anything is healthy or not, whether it's a lifestyle habit or an environment, is to paint a holistic picture using various different hard sciences, things like biochemistry, anthropology, comparative anatomy, chemical anthropology, things that can actually inform us on cause and effect. And so this is how I'm going to be approaching all three aspects in this video. Now, the main issue with seed oils from a biochemical perspective is the unnaturally high concentration of omega-6 polyunsaturated fats. The reason this is an issue is because polyunsaturated fats are the least stable in terms of their chemical structure. This is because they contain multiple double bonds between their carbon atoms, hence the term polyunsaturated. Whereas monounsaturated fats have only one and saturated fats have none, making them the most chemically stable. You can see a manifestation of this at room temperature. So poly and monounsaturated fats will be liquid at room temperature, things like industrial seed oils being polyunsaturated fat and olive oil being monounsaturated fat. Whereas most of your animal fats like tallow, butter, or any animal fat on a piece of animal tissue is going to be saturated fat. Hence it's solid. Now, why is this a problem? Why are these double bonds contained within the chemical structure a problem for us biochemically? Essentially, it's because each double bond contained within that chemical structure is a vulnerable point that makes it more susceptible to oxidation. Unlike large ruminant herbivorous animals like cows and deer, for example, we don't have the ability to convert unstable fats like these polyunsaturated fats into saturated fats before we store them on our body. So all of the fats that we consume as a part of our diets become incorporated into our cells, into our tissues. They're stored in our skin and everywhere around our body. If we're consuming mostly saturated fats, our tissues are going to be made up of mostly saturated fats. Whereas if we're consuming an excessively high amount of these polyunsaturated fats, that's what most of our tissues are going to be made up of. So in simple terms, you consume these polyunsaturated fats, they're more prone to oxidation because they're unstable, which makes them more likely to break down into these reactive compounds, which then go on and damage your body. This is why it makes much more sense to consume a diet higher in saturated fats. They're more stable, making them less prone to oxidation, and as a result, creating less damaging byproducts. And the thing that's so concerning with seed oils is, again, the accumulation over years and years. Because we store fats in our tissues, the more and more we consume, the more of our tissues become composed of these highly reactive fats, leading to more oxidation and then more damaging byproducts. These reactive byproducts then go on to damage the rest of our bodies, including things like our endothelial cells, which can then eventually lead to heart disease. So that's essentially the biochemical argument against seed oils in a nutshell. I now want to pair that with an anthropological argument. First of all, when we look throughout history, we can analyze through nitrogen isotope testing, which is an anthropological tool that I'll touch on later. But it essentially shows us what most of the food we ate consisted of throughout our history. And it quite clearly shows that we were consuming mainly animal flesh, indicating that most of the fatty acids we were consuming were in the form of saturated fats. The approximate estimate of the polyunsaturated fatty acid consumption was about 1 to 2% of total calories, whereas today it's estimated to be about 15 to 20%. So that's about a 20-fold increase in the amount of polyunsaturated fat that we've been consuming. And I think it's quite clearly had an effect on our health. So what I'm going to do now is analyze what we see in nature, because I think that that's a much more accurate way to arrive at a conclusion, because we're not speculating on what we did in the past. We can actually analyze what's happening in nature now. And so when it comes to the prevalence of these polyunsaturated fats in nature, what we find is that the further in latitude we go from the equator, the more prevalent we find these fatty acids contained within animals and plants. And this makes perfect sense to me because these unstable fats remain liquid at room temperature, which means they would make the cell membranes of these plants and animals more fluid, allowing them to remain warm. They essentially act as a form of biological antifreeze. This is why all of the seeds in which we extract these oils from are found in colder climates. Things like soybean oil, sunflower oil, canola oil, and also things like cold water fish, which are very high in omega-6. When we move closer to the equator, however, what we find is a higher saturated fat content within the foods. Things like coconuts, palm oil, cacao butter, all of which are primarily saturated fat. This biological antifreeze analogy also makes perfect sense when you look at hibernation. For example, bears will consume a very high amount of these fatty fish before they go into hibernation. This is again because it has the same effect. It makes the cell membranes more fluid and therefore allows them to generate more heat. You can also speculate that this effect is causing their metabolic rate to slow down because their cells are more fluid, they're more inefficient. And this actually serves a purpose because the bears want to hold on to more of their stored fat throughout the winter. And the way to do that is to slow down their metabolic rate so they're not oxidizing as much fat. As humans who live in warm climates, or even if you live at a higher latitude, you have a house with heat in it, you're not being exposed to the harsh winters and having to hibernate like a bear does. It doesn't make sense to consume a lot of polyunsaturated fat. And this is why I think that seed oils have exacerbated the obesity problem, because they're essentially having the same effect on our bodies as they would a bear that's hibernating. It's slowing down our metabolic rate and increasing our propensity to store fat. And this is kind of a double whammy because not only are you storing more fat as a result of your decreased metabolic rate from these polyunsaturated fats, but most of that fat tissue being stored is being composed of these polyunsaturated fats as well, leading to more oxidation and more reactive byproducts. You also have to consider the nutritional value of these seed oils, which is something that goes overlooked in our society today because we're always so focused on kind of just trying to fill our stomachs with food to reduce calories and lose weight, but we hardly consider the nutritional value of these foods. And when it comes to seed oils, you have to ask yourself what you're really getting when you compare it to its animal food counterpart like butter, tallow, or ghee. Butter, for example, contains plenty of essential nutrients like the active form of vitamin A, B12, D, K2, E, choline, as well as plenty of essential minerals like phosphorus, calcium, potassium, and magnesium. Whereas industrially produced seed oils contain pretty much nothing except a little bit of vitamin E and a little bit of vitamin K, while also being very high in polyunsaturated fats. So again, this is why it's important to paint the whole picture using various different hard sciences, as opposed to just viewing it through the mainstream lens. Because the mainstream lens is going to tell you that we don't have any outcome studies showing that seed oils have any negative effects. In fact, we have a few outcome studies showing that seed oils decrease your risk of heart disease. And when you do end up painting that picture and viewing it from my lens, you come to the conclusion that you probably shouldn't be touching seed oils. They're high in dangerous polyunsaturated fats, which are very prone to oxidation. In nature, they're found in cold climates, and their utility is to keep an animal warm and slow down its metabolic rate for hibernation. And they're destitute of nutrition compared to their animal food counterparts like butter, tallow, and ghee. So you're not getting any nutrition from them. They're potentially slowing down your metabolic rate, and they're oxidizing in your body, creating damaging byproducts. I think the verdict is quite clear on seed oils. Okay, let's move on to the second aspect of the modern diet, which I believe to be accelerating many diseases, and that is the constant upregulation of the Randle cycle. Now, most people have probably never heard of the Randle cycle unless they've already done their own research into the alternative health space. But this mechanism may help explain why the modern diet causes so many metabolic problems. This is kind of one of those things that goes under the radar and you wouldn't perceive to be a problem initially until you actually understand how it works. So the Randle cycle is essentially a mechanism that your cells deploy to regulate whether they oxidize glucose or fatty acids. Whenever carbohydrates are available, they'll oxidize glucose, and whenever fat is available, they'll oxidize fatty acids. The problem begins when a large amount of both of these two substrates enters the bloodstream simultaneously. This is because both fatty acids and glucose cross-inhibit one another's use for oxidation. Whenever a cell is primarily oxidizing fatty acids, it will reduce its use of glucose and vice versa. It's not so much of an on or off switch as it is a sliding scale. So whenever a cell is primarily oxidizing glucose, it will slowly reduce its use of fatty acid and vice versa. And it does this through the inhibition of very specific enzymes. So the way your body oxidizes fuel is the fuel will enter the bloodstream after you consume a meal, whether it's carbohydrate or fatty acid. Those substrate will be taken into the cell cytosol, which is the first layer of the cell membrane, and then taken into the mitochondria to be oxidized for fuel. I'll put up a graphic here to better explain it, but essentially, if a cell is primarily oxidizing glucose, it will directly inhibit CPT31, which brings fatty acids from the cell cytosol into the cell mitochondria. And in the case of fatty acid oxidation, it will directly inhibit GLUT4 right at the top, which prevents glucose from even entering the cell, while also inhibiting PFK1 and 2, which is the first step to converting glucose to the pyruvate molecule, which is required for glucose oxidation. So in the case of fatty acid oxidation, glucose is being halted right at the start. Any that's already in the cell is being stopped from continuation, and it's being halted right at the entryway. So glucose is prevented from even entering the cell. In the case of fatty acids, if a cell is primarily oxidizing glucose, fatty acids are allowed to enter the cell, but they are inhibited at the mitochondria. So fat can pool into the cell cytosol as much as it wants, but it cannot enter the mitochondria for oxidation while it is primarily oxidizing glucose. Now, this can be problematic for various reasons. It can lead to diabetes over time, propensity to store fat, as well as inflammation. Now, regarding diabetes, the reason this can contribute to diabetes is because when you consume a meal high in fat and high in sugar, let's say half of your cells are going to be oxidizing sugar and half are going to be oxidizing fat. Of the 50% that are oxidizing fat, those cells are all inhibiting the GLUT4 transporter, which you saw on the graphic before, which is preventing sugar from even entering the cell. The reason that during fatty acid oxidation, glucose is inhibited at the GLUT4 transporter from even entering the cell is because glucose is extremely toxic and can cause glycation. So this is essentially a protective mechanism employed by the cell. Whereas in the inverse scenario where glucose is being primarily oxidized, fat is still allowed to enter the cell. It is just inhibited at the mitochondria level. This is because fat does not cause damage the way that glucose does. Glucose is a toxic chemical. So what happens is when 50% of your cells, just for intents and purposes, are oxidizing fatty acids, those cells are all locking out sugar from entering the cell. As a result, it has to remain in the bloodstream. This is the exact definition of type 2 diabetes, elevated blood glucose. And the reason type 2 diabetes is so damaging and potentially even lethal in many cases, or can at least accelerate other diseases and accelerate your chance of dying essentially, is because of how toxic glucose is. When it's elevated in the bloodstream, it's damaging red blood cells, epithelial cells, plenty of other cells, causing inflammation, increased risk of heart disease because it's damaging the epithelial cells of your heart, and various other problems. It's also the reason why many diabetics have to amputate a body part. For example, they might have to amputate a foot sometimes because it's been so damaged by the glucose. Now, when it comes to obesity, the reason that it may accelerate this process is because, once again, any cell that is oxidizing glucose or fatty acids is inhibiting the other one, meaning it has to remain in the bloodstream, or in the case of fat, it can pool up in the cell to a certain concentration, but then the rest has to remain in the bloodstream. Now, when fat remains in the bloodstream, it's not toxic like glucose, but it's going to be stored as body fat in the form of triglycerides, as well as glucose. It's just that when glucose is in the bloodstream, between the time period of it being stored as fat and being in the bloodstream, it's creating a lot of damage. Again, this is why type 2 diabetes is so harmful. But just in terms of obesity, over time, chronically having this issue is going to increase your propensity to store fat because of how much substrate is being locked out of the cell and remaining in the bloodstream. And lastly, when it comes to inflammation, this one is more biochemical. Again, I'm going to have a video coming out specifically on seed oils, the Randle cycle, and the next thing I'm going to be talking about. But the reason it causes inflammation is because if a cell is oxidizing fatty acids, think of it as an assembly line or a highway where all the cars are driving at a nice, steady pace and there's no traffic. When glucose then wants to enter, think of it as a highway ramp causing traffic. All these cars want to merge and they're slowing down, they're kind of slowing down the assembly line or the highway. So it's causing strain on the mitochondria, which can cause inflammation in a nutshell. And again, I will have a separate video going much more in depth on these topics and the biochemical processes by which this happens. But for the sake of this video, I just want to cover the main piece and what the problems are. And so think about this. Most of the modern diet is a combination of a decent amount of protein, probably not enough to be honest, and then a balance between high carb, high fat, especially people who eat quote unquote unhealthy. So if you're eating 3 or 4 meals a day consisting of high carb, high fat, which is what most people do, you're creating chronic systemic inflammation, which is the underpinning cause of many of these main diseases. Once again, you're elevating your blood glucose, causing glycation, which can eventually lead to type 2 diabetes. You're increasing your propensity to store fat, leading to eventually obesity. All of these problems are a result of this Randle cycle upregulation happening multiple times a day. And the reason this one goes under the radar is because people will consciously think they're eating healthy, like maybe they're eating eggs with whole wheat toast or fruit with their eggs or steak and potatoes, which, yeah, the steak's healthy, but even if the mashed potatoes are viewed as, a healthy starch with a decent fiber content, it's the same thing as eating a piece of cake or Lucky Charms with milk because you're elevating your fat and carbohydrate intake simultaneously, regardless of what source it's coming from. So whether you're eating healthy or unhealthy, these foods break down into the same molecules in your bloodstream, glucose and fatty acids, and they upregulate the Randle cycle, causing the same issues regardless of what foods you're eating, as long as you're eating some significant amount of carbohydrate and some significant amount of fat. So that's the main biochemical argument behind why consuming a high amount of fat and carbohydrate simultaneously can be harmful. Now I want to get more into the natural and anthropological argument. Now, the argument here is actually pretty simple because when you look in nature, you only find foods that are either high in protein and fat or high in carbohydrate and protein. You do not find any foods that contain a high amount of carbohydrate and fat simultaneously, with the one exception of a mother's breast milk, which makes perfect sense because a baby is rapidly growing. It needs all of that energy and it's trying to store as much fat as possible. So in nature, you're going to find animal foods, which are going to be high in fat and protein, And then you're going to have plant foods, which are going to be high in carbohydrate and protein. You also have to consider the diets of every other species. So, pretty much every other species or mammal to most resemble humans is either hypercarnivore or hyperherbivore, being defined as 70% or more calories from that source. You'll see the term omnivore thrown around because some animals do eat a little bit of the other. So, like, for example, gorillas might eat a little bit of bird or a few animals here and there, but it is a herbivore. Its diet is primarily plants, and maybe you don't really see carnivores feeding on plant material, but maybe if a lion was starving, it might eat some grass. I've heard that was a thing, but the point is, even though they're omnivores, because they technically do sometimes deviate from their diet, although very minimally, they are hypercarnivore or hyperherbivore. A true 50-50 omnivore doesn't really exist in nature. And that doesn't prove necessarily that humans couldn't be the only ones, because humans could be unique to every other animal, which we are in many ways. But I think when you look at the evidence, it's quite clear that we aren't. And this leads me directly into the third thing that I wanted to discuss in this video, which is the consumption of biologically inappropriate foods. Now, as I've alluded to and discussed various times throughout this video, each species has its very specific niche diet that it eats. Humans are similar in that case. Humans have invented this concept of a balanced diet where we consume a little bit of everything to apparently extract all of the different nutrients we need. But in nature, is an animal specific diet not balanced? Like, is grass not a balanced diet for a cow? Does it need something else? Or does it extract all of the nutrients it needs from grass? Does a lion not extract all of the nutrients it needs from animal flesh? Why would it need a balanced diet of multiple different things? We've already established that consuming a diet that's inappropriate for one's biology can result in severe and rapid health degradation. And I think that the consumption of seed oils and the constant upregulation of the renal cycle causing chronic systemic inflammation, type 2 diabetes, and obesity are two of the biggest manifestations of our deviation from our natural diet. And once again, these diseases didn't just appear out of thin air. They have a cause. Something caused them to happen. So the pressing question then becomes, what is our naturally biologically appropriate diet? And to answer that question with the greatest possible accuracy, you need to undergo similar processes that I've been undergoing throughout this video. You need to analyze it from a holistic point of view using various different hard sciences like biochemistry, anthropology, comparative anatomy, things like that. So what I want to do in this section is make my case best I can as to what I believe the optimal diet is by going through each one of these hard sciences and giving you the best argument from each one of them. So starting off with comparative anatomy, the biggest and most significant inference we have here is our lack of a cecum in human beings across the population. A cecum is a huge component of a herbivore's digestive tract and is required to break down fiber specifically, as well as tough plant material. Fiber being contained within almost all plant material. So if an animal does not contain a cecum, this indicates that it is not able to digest plant material and fiber, and as a result should not be consuming those foods. Now, the biggest biochemical inference that I believe we have is our capacity for gluconeogenesis, which is the process by which we create endogenous glucose from non-glucose precursors. The body can produce all of the glucose that it requires from amino acids and fatty acids, but primarily amino acids, which will come mainly from consuming sufficient protein. Now, just because something is not required does not mean that it cannot be beneficial. So for me to just say, well, glucose is not required because of gluconeogenesis doesn't mean that it's actually beneficial. However, when you think about it logically, it's quite clear that humans aren't adapted to having elevated blood glucose, as demonstrated by type 2 diabetes being a disease which accelerates death and many other diseases, causing a lot of harm to the body. And then you consider that humans have a gluconeogenic efficiency similar to that of hypercarnivores, which thrive off of not consuming carbohydrates and have the ability to produce the exact amount of glucose the body requires without producing excess that can cause damage. So then you have to ask yourself, why would we consume carbohydrate? I think the picture is quite clear that you probably should not be consuming any significant amount of carbohydrate. The next biochemical argument I have is one that I alluded to very early on in the video, which is that humans, like lions, do not contain the enzyme cellulase. So when you consider that we don't produce cellulase and we don't possess a cecum, it becomes quite clear that plants are not an appropriate food for us. So the next field is anthropology. And I already stated that I'm not a huge fan of anthropology, even though the main consensus on its conclusion concurs with my conclusion. It's not my favorite piece of evidence, and I don't think it's the strongest piece of evidence. Contrary to what many people who are in agreement with my conclusion will say, they actually think this is the best conclusion or the best piece of evidence to concur with the conclusion. But I look at it as more of a valuable piece of evidence to use in conjunction with other arguments. I wouldn't use it as a slam dunk. Again, this could be an appeal to incredulity because I may not understand it, as well as the others who proclaim it to be the best piece of evidence. Maybe they have a better understanding of anthropology, but I'm just always suspicious about claims being made about 4 million years ago, 10 million years ago, 100,000 years ago, even. Just astronomical claims like that always trigger some level of suspicion in me. So I'm always skeptical of it. But nonetheless, the anthropological evidence does concur with my conclusion. And I must say that the most compelling evidence of this is what's called nitrogen isotope testing. Essentially, how this works is researchers will extract collagen from human remains and analyze the nitrogen 15 to nitrogen 14 ratios, which are both stable isotopes of nitrogen. Stable meaning that they're not radioactive and they don't decay in the same way that unstable isotopes would. So generally how it works is animals that are higher up in the food chain display a higher level of nitrogen 15 values. And all of the analyses of human remains have demonstrated a nitrogen 15 to 14 ratio comparable to apex predators, even higher than some of the ones we know today like lions and hyenas. And while I agree that anthropology is a hard science, I'm just, like I said, always skeptical of astronomical claims made about how many years ago this was. Some of them claim to be millions of years ago. So the argument is that we've been adapted to eat this way for millions of years. I would agree that we're adapted to eat this way based on all of the anatomical inferences and the biochemical inferences. I just question the length of time, whether it really was that many years ago. So I guess you could say it doesn't really matter. But then again, this argument would be incomplete on its own because it would be fallacious to say that just because we ate this way in the past, it means that we should eat this way today. Because theoretically, if the people of the future took isotope data that was representative of what we eat today, it would be telling them to eat Pop Tarts and Twinkies. So I don't think that would be quite helpful in terms of determining what they should be eating. So again, this is the importance of painting the entire picture using all of the evidence together. And when we do that, the picture becomes quite clear about what we should be eating. Humans are unable to digest plant material and should not be consuming it. Humans should not be consuming carbohydrates because above a certain level, they're extremely toxic and the body produces the exact required amount that it needs very efficiently. Humans should not be consuming a significant amount of both fat and carbohydrate, as this can upregulate the Randle cycle and lead to a whole host of other issues. This indicating that we should either consume a diet high in fat and protein or high in carbohydrate and protein. And when you consider what those two diets would be composed of, the high carbohydrate one would be exclusively plant material with no animal foods, and the high fat one would be exclusively animal foods with no plant foods. And it becomes quite clear after every inference we have that animal flesh and fat is the biologically appropriate diet for human beings. And we can also jump out of this theoretical plane that we've been in this whole video and into reality, where we'll find countless anecdotes from countless people who have improved their lives and health from adopting this way of eating, putting so-called incurable diseases and illnesses into remission. I would never use anecdotes as the backbone of my argument. However, they are extremely powerful and something that science can't buy. But in this case, with all of the evidence we have, I consider them to be the cherry on top. So that completes my thoughts for this video. If you made it this far, I appreciate you. I hope you enjoyed it. And most importantly, I hope you learned a lot. Stay tuned for more videos.